Okay, now we're ready. The sound working? Good, okay. So number 16. It says y is a function of x such that y prime is greater than 0. Okay, when you read that, you need to be able to translate that from math to English, kind of. So we've got a set of xy pairs. That's y is a function of x. And those xy pairs, the rate at which they change is always positive. So if you have a bunch of xy pairs, and the rate at which those xy pairs are changing is always positive, that means as x goes up, because we read graphs left to right, the y values are going up. The y values are increasing. And Danica's chart summarizes that very quickly, because they're talking about this function here, which we'll name f, and they're saying, hey, the rate at which f's xy pairs change, that's f prime, and that f prime value is always positive. That means the xy pairs are always going up on the graph of f. Questions from anyone? This class is really good at questioning, so just keep doing it. Keep reading. And y double prime is less than 0. That one's a little harder to see, but Danica's chart summarizes it really well. If the second derivative is always negative, that means the slopes of our function are actually decreasing, which means f must have a concave down shape. So raise your hand if you know the answer. There we go. 75% of you. Let's go Brinley. So Brinley's voting B. Very appropriately for Brinley. How many are voting B, Sean? 2 more. Okay. So look, the first clue right here. Y prime is greater than 0. This is your graph of f. And they're saying f has to go up because every slope of f is positive. Every slope of f is positive, causing f to increase. So that matches. But then it also says that the second derivative of f is negative, which means the slopes of f have to be decreasing in value little by little. And they are. This slope is positive, but then the next slope is less positive. The next slope is even less positive, etc. So B is the correct answer. It matches both requirements. You want to talk, please, Scarlett?
Can you go over a little bit more on how you use the chart to find that answer? I'm struggling seeing where you went to on the chart.
You're good. So as I read, they tell me y is a function of x. That says there is a set of xy pairs that we're talking about. Good with that? Cool. It says for those xy pairs, the rate at which those xy pairs change, that's the symbol y prime, is always positive. So all of these numbers here are going to be positive numbers, indicating that the numbers you see here have to be increasing, because that's what a positive rate of change means, is that the values of the y values themselves have to go up, because this is indicating the rate at which these, so this indicates the rate at which these things change. So if you look at C, very good. So these xy pairs are not increasing, they're going down. And we can see that by saying, well, let's look at the slope at each point. What's the slope right here, Scarlett? Positive or negative?
Negative.
Negative. How about here?
Also negative.
Also negative. That's because these xy pairs go down. Therefore, the slope at each point has to be negative, causing the xy pairs to go down. So C is wrong, because for C, f is decreasing, which means f prime would have to be negative, but the clue was that f prime is positive. So it can't be C. Can't tell if that helped or not, though.
Yeah.
Okay. Our clue was that f prime had to be positive, which meant f had to be going up. So that made A possible, B possible, and E possible. D can't be true either because D has a section where D goes down. Then I go on to the next clue, which is the second derivative of my xy pairs has to be negative. So I look at Danica's chart. Danica's chart has 3 columns relating the function's xy pairs to the rate at which those xy pairs change, to the rate at which the rate actually changes. That's what these words are for. These are the xy pairs, just the amount, I call that. This is the rate at which those values change. RR stands for the rate at which the rate itself is changing. So they tell us that y double prime is a negative value. That's here. Well, that means that the slopes of f have to decrease. So if we go here, we'll get Eden to help me for a second. So Eden, C is wrong.
Yeah.
Is that slope positive or negative? Negative. Actually, let's ignore that. We know C is wrong. Let's go over here to, like, say E. That doesn't. Let's go to A. So right here, Eden's slope, positive or negative? How about this one? Positive again. This one, Eden. Positive again. 2 points for Eden. Isaac, as you compare the red to the green to the blue to the yellow, would you say the values of those slopes are increasing? Would you say the values of those slopes are decreasing?
They're increasing.
They're increasing. When the slopes of a function increase, the function will be concave up, and the second derivative will be positive. But we need the second derivative to be negative. That's why we pick B, because for B, the slopes are decreasing, and that causes the curve itself to be concave down. Please.
So why isn't it E then?
So let's check E. 2 more for Charity. So for the first clue, Charity, the slope is supposed to always be positive. So right here, Charity, positive or negative slope?
Positive.
Good. How about here?
Positive.
It's getting kind of boring, but keep going.
Positive.
Keep going.
Positive.
One more to finish up the...
Positive.
Okay. So all the slopes are positive, so E does fit the first clue.
Yeah.
Now we check the second clue. The graph is supposed to be a graph where the second derivative is always positive. No, sorry, backwards. Always negative. That's what this says. Which means our slopes are supposed to be decreasing in value 1 by 1, which will cause the shape of f to be concave down. Well, blue slope is what again, Charity? Positive or negative?
Positive.
And the yellow is?
Positive.
But as you go from blue to yellow, are you getting more positive or less positive? So that's an increasing slope. Like the slope is increasing in this area. That violates this clue. So this graph of E is both concave up and concave down. So it cannot match the clue they gave us. 2 more. Scarlett, I don't know if I helped your question.
Yeah.
Okay.
Thank you.
Anybody else? Please, London.
let's say E was the correct answer, what would 16 be saying if E was the correct answer?
Oh, awesome. So this clue would still work, but they'd have to change this clue to something more complex, like a y double prime is going to be greater than 0 for all x's that are less than 0, and then y double prime is going to have to be less than 0 for all x's that are greater than 0. The way to quickly do that is this, London. This E is concave up to there. That means if my set of xy pairs are concave up, that means my slope is steadily increasing. That means my second derivative has to be positive. So that's what I wrote. The second derivative is positive whenever the x coordinates are less than 0, which is what we have going on over here. So when the x coordinates are less than 0, f is concave up. Then when x becomes positive over here, that's this clue. Now we have the second derivative is negative, which means our slopes are decreasing and the function is now concave down. So that's what they would have written to change the problem so that E becomes the correct answer. Two more. Cool. Stop the video, do another one.